Morning, everybody. Kind of a weird night. I didn't know if I was going to be here today, but this kind of cold's getting me down. But I'm okay. I wanted to fill in some of the blanks from last time. By the way, assignment. Here's what I decided. I mean, ideally, this assignment should be due after Friday, but that doesn't make sense because then there's this break thing, and so here's what I'm going to do. I'm going to have the assignment due Friday, but we're going to handle Friday a little differently. I mean, Friday I want to go through a few more things, and then I'll go through some questions actually on the assignment, and I might even give you a little time to work on the assignment, but of course we won't have computers here. So anyway, I want your assignment to be ready to go Friday. I was thinking about that, having an assignment due over break. It's just too long of a break. Probably not ideal. So our goal is to get through everything you need to finish the assignments today. Okay. I wanted to start with this. It's this thing in the bottom right corner called, you don't have to go look at it right now, but there's a list of facts. You can go look whatever you want. Page 111. And you can't tell what I did there. But do you see how in the blue there are these scatter points, scatter plot, and you can see there's a black best fit line sketched in. What you're probably wondering about is what are the red lines? And that's what the fact is about. Fact 3 says the point, the average of x, the average of what? See, what I'm trying to show you here is this line right here is well, and this line right here is x equals x bar. And so this point right here where the two red lines intersect is x bar, comma, y bar. Now, do you remember what we mean by the bars, right? The mean of x, the mean of y. So here's the cool fact. It says the point x bar, comma, y bar is always going to be on your regression line every single time. Do you see how that point where the two red lines cross is on the black line? So this turns out to be very valuable. X bar, comma, y bar will always lie on the regression line. Now, you guys remember that when you're doing a y equals mx plus b, if I could skip around here a little bit, when you're doing one of those y equals mx plus b problems, how did we get the last part to b? Didn't we have to substitute in a point? Remember that? Well, guess what? If you don't have a point, this will always give you a way to have a point. Well, maybe not. I shouldn't say always. It depends on what they give you. But we're gonna do a problem today where we don't know what all the x's are, but they do tell us what x bar and y bar are, and therefore, because we know this fact, we know that x bar, comma, y bar is a point that really is on our line, and so we can use it to find b. So that turns out to be really useful. So periodically you're going to see me draw a scatter plot, and you'll see me put these two red lines on there. I'm just trying to remind you that the average of x, the average of y, and where they intersect, that point will always be on our best fit line. Okay. Yeah, let me just show you what I was doing here, and then we'll later get to a real example. But here's an example where I did a scatter plot and I did a regression line, and then the book said use your regression line to make a prediction. You're going to find that this is going to come up. Make a prediction. That is, you know, in this case they might have said, well, if x is 42, what would you predict to be the value for y? The answer is, I'd go over to 42 and I'd go up until I fall on my best fit line. And when I hit there, I can read off to the side and say, oh yeah, okay, my predicted y value is 43-ish, or somewhere in there. Now, of course, you do that with great caution. Predictions are always fraught with danger because, you know, how do we know this pattern is going to continue? And so you would probably, if I was writing up a report, I would say, well, if the current trends continue and the conditions stay similar, then I can predict that for an x value of 41, my prediction is y would be 43, and then you can even say what degree of confidence you have. That's the r squared. So, prediction is a big part of this chapter, but again, I wanted to say do it with caution. I mean, you don't have to write in your assignments if, but this is a big deal. Just beware. Guess what? They're not perfect, just like the weather forecasts aren't perfect because conditions change. And how do we know all the conditions are going to stay the same? You know, I'll give a good example. About a year and a half ago, we could have looked at housing costs, the average housing costs in, let's say, Milwaukee County. And we could have looked at a graph, and I think we'd probably have found it was fairly linear and heading uphill, which means, wow, if you can hang on to your property, maintain it well, it probably should gain in value. And now if you made a prediction, wow, cool, 5 years from now, my property might be worth, and you could go out on that line. Guess what? Things have changed. The graph has changed. Yeah, and I say that with sadness in my heart because I'm a property owner too, and that means that things have not grown like they said they were. In fact, I just saw on the national average, I think housing costs have gone down 9%. That hasn't happened for a long time. So, anyway, there's a good example of a pattern that has changed. And so if we made a prediction, we'd have kind of fallen flat on our face with a prediction. Yeah, here's another one of those prediction models. Let me just show you this one. Do you remember the cars and the city mileage and the highway mileage? You've seen this problem over and over too. Okay, there's a scatter plot. I've got the regression line. Well, problem 5.3, which is one of the problems that you're going to have assigned to you, asks you to make a prediction. Okay, well, first they say, make a scatter plot and find the equation. Well, you know Excel will do that for you, right? Little right click, hover over one of the points, right click, add trend line, and then check those last two boxes, add equation, and show r squared. And there it is. Pretty strong correlation. Wouldn't you agree, even though I don't have it listed here? Okay, now the question is, what is the slope of the regression line? Well, it's always sitting right by the x, isn't it? Please don't do this. I have a lot of people who do this when they tell me the slope. They think it's 0.856x. No. The slope is just a 0.856. Okay? Just the thing that's multiplied by x. So anyway, what's the slope? 0.856. Now, since this is quite high, this is 0.856 is a strong, well, I shouldn't say that. Since we can see the correlation is high, this is pretty good. This is a pretty good model for predicting if it continues. The book goes on to say, in part C, it says, what would you predict if there's a 20 mile per hour mileage in the city? What would you predict would be the highway mileage? And again, start at 20 on the city axis, move up to your regression line. When you hit it, And you can, again, it's not real easy to read, but it looks like, what, about 28, 27 would be our prediction for the highway mile. And so there's another example of a regression line being used to kind of make a prediction. So I guess you could say this is kind of reading between the lines. Using the regression line. Is it perfect? No, because does every point lie right on that line? No. But because they're pretty close, we can with fairly good confidence say it should be about that number. So that's this predicting technique again. Okay, we're going to talk a little bit about residuals. First of all, did I make clear what residuals are? Residuals are the distances that each point is from the best fit line. And some residuals are positive, like the one, all of these on the top. And there should always be some negatives, meaning this is below. So we got all these negatives down here too. And what should happen when you add those distances all up? If we did it right, it should come out to 0. So in other words, there's a balance of the ones above, the positives, and the ones below, the negatives. Sorry. My cough really changed too. I sound like a wounded goose or something when it rips out. Sorry. Go ahead and laugh if you want when it happens. It's all right. Okay, so if you add up all the residuals, you'll actually get a 0. I'm going to try to show this to you by, we're going to do a problem. I want to show you, and another thing I want to show you is in Excel, how can you actually find the residuals, and there's a way to do that. I haven't shown you yet. We'll try cough drop. So do you see what this says at the bottom of this page? It says to calculate residuals, you simply take the real point's height, y, and subtract the predicted height, the one that, so subtract the real height of the point minus the predicted height of the point. So, and what are you going to get? You're going to get this length. Okay, what happens here when you subtract real height, right there, minus this guy up here? You're going to get a negative on that one. Yeah. So. Now, I want to just talk briefly about residual plots. Actually, I'm probably not going to have you do residual plots, but I at least want to show you what they look like. Okay? You take all these numbers, half positive and half negative, and you can plot them on a graph with, the 0 mark kind of highlighted. You're going to have some above, some below. And so, that's all there is here. If we did things right, you're always going to have a total balance between above and below. But I'm not going to have you plot those as much as I'm going to just want you to know that there's half positive and half negative. I think what we're going to do, oh yeah, I want to show you this. Do you remember that I called, another name I called this line was the least squares regression line? Does that ring a bell from last time? I want to actually demonstrate. This is pretty cool. There's a little applet. I got to go to the browser. There's a little applet that shows this real clearly. Do you see that we have this blue line here is the least squares regression line, and then all these little red points are our data points. Okay. Now here's the idea. As a point, I'll tell you why are all these squares up there. Here's the deal. You take this point like right here, P4. Okay, this is what? The residual, right? Right. The vertical distance, it's away. And if you take that number and square it, geometrically, wouldn't that give you a square of that length? Okay. And then this point, smaller residual, smaller square. The idea is, if I add up all those squares, I get this guy. And we want this guy to be as small as possible. So watch now, you can do this live. As you grab a point and move it closer to the line, I'm going to grab this P2. You see how the square gets smaller? You notice the red square gets smaller too, the total? So if I move all these points a little bit closer, what happens to the total of the squares? Well, the red square is getting nice and tiny, and the tinier that red square is, the better our line fits the points. And so it's actually a graphic view of all these squares being added up, and you want that to be as tiny as possible. I thought that was kind of a neat way of showing you that. So anyway, yeah, residuals, the long and short ways. Well, what's the long way? Take each point and subtract. What's the short way? Well, we're going to do one. So I guess maybe now is the time. Oh, by the way, do you see again on this scatter plot, I have once again sketched in X bar, Y bar to show you that where they cross, those two red lines, that point will always be on the residual line. Okay, so let's take some data. What should we use? I suppose we could use the icicle growth on in table 4.2. Then I got to go back. All right, that's okay. Chapter 4, table 4.2. Could use anything, but this is a table that has something to do with temperature related to icicle growth. Okay. Now, please note, there are different, what they call runs. There's run 8903. All of these are 8903s. And then, do you notice right here, it's called run 8905? We're only going to do one of those. Okay. So let's take 8903. Let's make, just for the fun of it, let's make a scatter plot. That's pretty good, isn't it? Pretty good correlation. Let's hover and let's get our right click and do our trend line thing. Okay, so look at the R squared on there. 99.9915. That means this is so good correlation that we actually have a 99% accuracy when we're doing predictions. So this is incredibly good. Okay, now, something I haven't shown you. Here's how we can actually get a listing of the residuals. Okay, so we will now go data analysis, but for the first time ever, we're going to choose regression. Didn't mean to hit that yet. Regression. Okay, click OK, and you got a dialog box again. Please note there's a separate input for Y range and input for X range. So one at a time. First they want the Y. So that's going to be the length. Then make sure you click in the input for X and then do the drag on that. Okay. Now, I got to figure out where we're going to do. I think what I'm going to do is do this on a new sheet. So I'm going to leave it at new worksheet, and I'm going to say I want to see the residuals. I might as well show you the residual plots. Let's click OK. So now it should open up a new worksheet for us when it's ready. There's, up in the top right corner is the residual plot. I'm probably, that just shows you that we have half of our numbers above, half of our numbers below, like we said. Here's the actual residual output. That means for each point, what's the difference in the y coordinates? Okay? There they are. The first point was a positive 1.4. Then a positive 1.02, etc. You notice some negatives showing up. Let me scroll down so you can see them all. It takes all the points and shows you the residuals. Now what I'd like to show you is that when you add these up, what should happen? Sure enough, we just had the computer add up the residuals. 0. Why? Because half are positive, half are negative. So, just to demonstrate to you. So, I think you might, I don't know if you're going to be asked, I think you're going to be asked to show the residuals. You're never going to have to do that manually. If you did have to, you just take the y value, subtract it from the part in the equation. But I'm not going to have you do that. So anyway, there's a list of residuals. I'll go through that one more time. You would, I got to go back to my, here's the sheet we were working on. Data analysis, and choose regression. Click OK. You're going to see a separate input Y and input and input X box. First, do your Y. Make sure you click in this box. And then do your X. You don't need to check this residual plots, just so you pick residuals. My recommendation is use a new page. This report is so huge that you can't really fit it anywhere small. So just leave it on new worksheet, click OK, and you get this. And I'll tell you, there's a lot of stuff up here. Bottom line is, what? Here's your slope, and here's your y-intercept. But we can get that by right-clicking on the scatter plot. But the residuals are always at the bottom, and there's your list right there. Now this first column is the predicted y. Those are the heights that y should be if it was right on the line. And this is the error, the residual. This one was 1.4 above. This one here was 0.799 below, etc. Okay? Does that make sense for residuals? All right. Now I got a couple problems. Let's see, am I ready for that? Yeah. Okay, I want to do two problems next from the book. 515, which is one of your problems, so it might be nice to pay attention. And then we're going to do 518, which is not an odd, but it's like ones you're going to have to do. Problem 515 is on page 124. So here we go. Sisters and brothers. How strongly do physical characteristics of sisters and brothers correlate? Here are the data on the heights in inches of 11 adult pairs of brothers and sisters. Verify using your, well, instead of computer, using your instead of calculator, using your computer, that the least squares line for predicting sister's height from brother's height is Oh, and the rest of it's on the top of the next page. It's actually 0.527x plus 27.64 if you use the mx plus b form. So let's verify that. All right, so let's get the data file. Now we're in chapter 5. $5.15. Okay, brother height, sister height. So we're going to make a scatter plot. Click and drag. Insert. Scatter. Okay. Hover. Right click. Add trend line. Check our usual last two down here. Click on close. I usually like to put the equation in a place where it's a little easier to read, so I usually drag it a little bit. So Excel is telling us that it's 0.527x plus 27.635. Just a hair more accurate than the book. The book had 27.64 for the y-intercept. But do you see that? All right, first of all, we have verified it. So Excel nicely agrees. You know, if you rounded 27.635 to the nearest hundredth, it would be what the book has. What's the second part of that? Part B. Damien is 70 inches tall. Can you predict the height of his sister Tanya? Well, with a little trepidation. Why? What's r squared in this problem? 0.3114. That means we can only do it with kind of a 31% accuracy. But so I would be real careful. So let me, yeah, I don't know. I can't really easily do this, but here's Damien down here, 70. And if you come up, hit the line right approximately here, don't you? And then if you move straight to the left, what height is that? I don't know, 64.3 or 64.4 or something like that. Do you see? So we can make a prediction, but you know, I would say only with 31% confidence. Mm-hmm.
Because they have two different brothers that are 70 inches tall, you couldn't just use that. Both brothers that are 70 inches tall, you gotta think the sister is 65.
Yeah, except that you notice they're not the same. Oh, they are. In this case, they're the same, so yeah, you could have. But usually when they ask you to predict, there's not going to be one in the table, and so you're going to have to, yeah, you're going to have to just do this line thing. Did you get what her question was? It was a good one. In this case, since there already are two brothers with 70 in the list, couldn't we have just read down and said, well, the sister, yeah, sister's probably going to be 65? A little different answer, though, than what we got, right? Based on the line, what did we get? 60? A little bit less than that. Do you see how we're below this? Not much, maybe 64.5. Okay. Normally, when they ask you to predict, it's not in the table, and you got to read it off the graph. Okay, so there's 15. Anybody see a question there? Let's look at 518. Oh, yeah.
What did we say?
Well, they just said verify. So.
It said, what is the correlation between them?
Oh, thanks. I didn't see that part. Yeah, way up there on top of the next page. What's the correlation? Well, how can I find it out from what you see here? Correlation is R, right? And what do we have right here? R squared. So a really easy way to do it is take the square root of this. Or we could go through that whole process, do data analysis, correlation. Why do it when it's almost right here? So all you got to do is If you got your calculator handy, 0.3114 square root. That's your correlation. Yeah, thanks for pointing that out. I skipped that. Yes?
For when you predicted like 70 to find out the inches, couldn't you just put it 70 in for X and then like...
Yeah, that's the more exact way to do it. Thank you. Instead of just visually doing it, you can plug 70 in right here, multiply it out, add 27.635. Now you got your prediction. I don't know how exact you want to get when you only have 31% accuracy, but yes, that's the better way. So, thank you for pointing that out. How can you make a prediction based on the regression line? The best way is use the equation. You can also do an estimate visually. Yeah, thanks for bringing that up. Okay, so we said we'd do 18. Let's move on to that. What's 5.18? IQ and school GPA. Figure 4.6, page 95. Well, that goes back quite a ways. Okay. Now, I noticed back there that they don't really have the data. All they have is the scatter plot. So this is a little bit unusual. And this is that one where we had that funny, spread on one end of the scatter plot. Remember that one? But look at what they gave us. Interesting things they gave us. They said, we're going to tell you X bar, we're going to tell you Y bar, we're going to tell you the standard deviation of X and the standard deviation of Y. Can you find the equation? Oh, this is cool, because it gets us to practice something else that we've learned, and that is, well, let me get a page here first. Guess I didn't show you a lot on here, but here we go. On 518. Okay, we know, let me write these facts down. X bar is 108.9. The standard deviation of X is 13.17. Y bar is 7.447. And the standard deviation of Y is 2.10. We're supposed to find the equation. Now, here's where we're going to begin. Do you guys remember this one? Oh, they gave us one more important thing, didn't they? I didn't read it yet. They gave you the correlation. Okay. Now, do you remember this equation? This is the way to convert a correlation into a slope. You have to take R multiplied by S sub Y over S sub X. So in this case, what does that mean? Take 0.6337, multiply it by 2.10 over 13.17. Okay, pull up the calculator and we'll do that. So we have 0.6337 multiplied by 2.10 divided by 13.17. And we'll get a long enough decimal. 0.101. So there's our slope. Now that's going to have to do for accurate enough. Now that we know our slope, and we know we're aiming for this, we know we're aiming for that form, we can plug our m in, and all we need to calculate is b, and we got it. Now, don't we need to substitute in a point? What are we going to do? They didn't give us any points. Well, our salvation is something I mentioned earlier today. What point is always right on the line? X bar, Y bar. So there's your point right here. Cool. I didn't mean to write there, but weird. I'm hitting things that I'm not. Okay, here we go. So let's plug in Y right here. And then here's X. And of course, I don't know why I didn't have the plus B here. So now, what do we got? That's 7.447 equals, a little multiplication here, .101 times 108.9, 10.99. Wow, so close to 11. I'm just going to put it at 11. And then all you got to do is subtract 11 from both sides, and we got it. So now we just need to take 7.447, subtract 11, and we get negative 3.553. Okay, so there's our equation. Y equals 0.101x. You can either say plus a negative 3.553, or you can just say minus. Okay, so let me just check. Where are we on the problem? We've done A. We got the equation. Part B, what percent of the observed variation in these students can be explained by the linear relationship? Isn't that always r squared? Well, can't we just square r and find out what that is? So, what's 0.6337 squared? Point 40.401. So 40.1% is our degree. What do they call it? The percent that we can, rely on that prediction. So this is the A answer. This is the B answer. Part C. One student has an IQ of 103, but a very low GPA of 0.53. What? Yeah. Of course, those are actual things that happen. People who seem to have adequate intelligence, but don't perform well. So, what is the predicted GPA for a student with IQ 103? Well, let's use the equation and find out. So what we're going to do is take 103, plug it in right here, and let's see what we get. Again, let's pull up our calculator. 0.101 times, what was it, 103? And then we want to subtract 3.553. Boy, something doesn't look right. I wonder if I made a mistake over here. 6.85 GPA doesn't make sense. So let me take a look at what I might have goofed on here.
On the table though, it goes all the way up to 12. Like the grade point.
Oh, for GPA? Oh, okay. Well, then it must not be a 4-point scale GPA. Okay. That would, so then my answer does make sense. I was going to say, wait, how do you get above a 4? But this must not be a 4-point scale. Okay. Thanks for saving me on that. So what was it, 6.85? Well, I wish I had a GPA like that. Have you guys ever heard of a GPA that high? Yeah, me either. Not on this planet, huh? Or not in America? Okay. All right, there's a couple problems for you. I think those are key. I wanted to show you too. I think I've got this ready to go here. Yeah. If you just, oh, by the way, I don't know if you noticed this, but there's a number of pretty good tutorials. Have any of you tried those? I'm going to just show you a few moments of one of them. They're pretty well done, and they're like little video lessons. I got them from some university in the state of Utah. They're really, really quite good. So let me just show you a quick peek here. Least squares regression line tutorial. Got to get my sound hooked up.
Principles of least squares regression. Before we begin our discussion, let's review
Excuse me.
in data analysis. We first plot our data and interpret the plot. Then we compute numerical summaries, and finally, we model the data where possible.
You can also, you can wait, or you can just start clicking on, like here's prediction.
Now for prediction.
So you can skip ahead to different
Can
parts.
the height of an 18-year-old male be predicted from his 4-year-old height? To answer this question, we first collect data. For each male, we have their height at age 4 and their height at age 18.
So anyway, some people have told me that voice is kind of irritating. I think after a while it is, but they're pretty well done. Anyway, if you wanted to review certain, you can click on any part you want to look at, which is kind of cool. You have control. Just wanted you to be aware those are there. Okay. Now, as far as the assignment, I've probably undone that now, so let me just go back to Genzabar. I think it's 1 to 41 odds. Some of you came in a little late. Right at the beginning, I mentioned that the assignment is going to be due Friday. I wanted it really to be due later, but it makes no sense to have it be due after the break. It's too big of a gap.
Do you still want us to do 1 to 41 odds? Because that's a lot.
Yeah, I really do. For 2 days, actually, most of the time they do that in one, but well, I'll tell you what. If you wanna, I'll tell you what. Well, I'll shorten it up. Why don't we do this? Right now, what is that? 20? Yeah. Because you got 1, 3. I'll tell you what. You pick out 12. Any 12 odds, and do 12. But you gotta make sure you tell me which ones you pick. You know what I mean? Like, if you pick 7, make sure you put a nice 5.7 up so I can see. So let's do that. That'll make it a little bit more manageable. And then, like I said, I think I'm going to handle Friday a little bit differently. I'm going to, maybe we'll actually have a little, workshop type thing where we might work on some problems. If you want to ask me about a couple, I will. Just be aware that not all of us are going to ask about the same ones now because you've got some choice. Now, you got to be, I know the temptation is, let's do 12 that are pretty similar and we'll get that baby done quickly. Honestly, that's not for your best interest, right? Because if you skip certain kinds, and then they're on the test. See, that's the thing I feel bad about by reducing yours. Because in a way, I'm hurting you. So just beware. I guess what I'm saying is try to spread them out, okay? And you can use Excel as much as you want. Okay. So what did I say, 12 odds? shouldn't do that. But I did.